Hello everyone, I'd like to apologize for my voice. I'm a little bit sick, but nevertheless, let's continue our journey. In this video, we're gonna create a basic level and a playable first-person character with a head bobbing feature. I hope you will find this video useful and interesting. Let's begin. First of all, we need to create the core of our game. I'll talk about each piece later, just be patient. To start with, go under Content Browser, look for the icon near Filters, click on it. It will show us our source panel. Then go right here, right click on any area, choose New Folder. Let's name it Blueprints. Then go into the blueprints. Here, right click on any area, choose New Folder. Let's name it Core. Here we will store all our game main logic. Go into Core, right click on any area, choose Blueprint class. Look for game mode base. Let's rename it BP_game mode. This class stores all of our game default key elements, such as character, player controller, HUD, etc. Then let's create our character. Right click, choose Blueprint class, look for character, click and rename BP player character. This class has movement components that can handle such features as swimming, flying, running, jumping, crouching, etc. Here we will store our controls and any abilities that we will create in future. The next element is player controller. It will handle UMG widgets for our UI and HUD. Right click, choose Blueprint class, look for player controller and rename it BP_player controller. Next, let's create player start, the class that handles our character's spawn area and spawn rules. Right click, choose Blueprint class, go to all classes, expand, search for player start, choose this one, not player start py, and select. Let's rename it BP_player start. The last element is gonna be game instance. There we will store our game settings. Right click, choose Blueprint class, search for game instance, choose this one, not platform game instance, then select, and let's rename it BP_game instance. Let's save our assets. Click on the first, shift click on the last, and use Ctrl S. Our assets are saved. After all classes have been created, we need to set up our character and player controller as default elements for game mode. Double click on game mode. When you open a blueprint for the first time, you will see the minimized version of it. Look for Open Full Blueprint Editor and click on it. Here, on the right side, look for a category named Classes. We need to change Player Controller class and Default Pawn class to our classes. Then, look for Compile, click on it, then click on Save. The next thing we should do is tell our game to use our game mode instead of the default one. Go to Project Settings, look for Maps and Modes, click on it, then in the category Default Modes, change Game Mode Base to our game mode. Also, in this tab, scroll down to the bottom and change Game Instance to our game instance. Then, navigate to Category Input. Here, we'll define our controls. Choose bindings according to your taste. We need to define our abilities to move forward, backward, move to the sides, turn around, look up and down, and running, crouching, jumping. We will start from the ability to move forward and backward. Choose Axis Mapping. Then rename the axis as you like. I'll go for Move Forward. The reason for choosing an axis is simple. It can have two opposite values from 1 to -1, where 1 is for forward direction and -1 for backward direction under similar bind. Add another axis. Here I'll go for W, move forward, and S, move backward, and change scale to -1. Let's continue. Here comes Move to the Sides ability. Add another axis mapping, rename it, add another X, A for the left, scale it to -1, and D, move to the right, scale 1. Then let's add ability to turn, add another axis, rename it, and we'll use mouse X axis. It's obvious. Then let's add the ability to look up and down. Add another axis, rename it, and we'll use mouse Y axis and scale it to -1, so it won't be inverted. Let's add another abilities. Go to Action Mappings, click. The first one will be for jump. Bind it to spacebar. Then let's add sprint or run ability. I'll go for left shift. And the last action is crouching. I'll go for C key. That's all for now. For other actions, we will return here in future. Close the project settings window and let's add controls to our character. Double-click on player character, then click on the Open in the full blueprint editor. Before we start, let's add a camera so our character will have eyes. Navigate to the left side of your blueprint and find the category named Components. Then choose Capsule Component, so when you add a camera, it will be the child of our capsule component. Click on Add Component and search for Camera. Rename it as you like. I'll go for FP Camera, First Person Camera. Then we need to rearrange its position. Click on Viewport to visualize. Make sure your camera is chosen and navigate to the right side of your blueprint. Here you can find the category name Transform, and in Location we need to change our ZX value. I'll go for 45 units. That's it. Don't forget to compile and save. Then go to the event graph and delete the default nodes. We will create the necessary ones when we need them. Let's add controls so our character can walk. Right-click on any area in the event graph and search for our actions we assigned earlier. The first one will be Move Forward. You need to choose Event, not Access Value. Make the same steps for our left actions. And that's it. Compile and save. We will now write the logic path so our character can actually move. Right-click and search for Add Movement Input. Then, you need to provide the direction and the value of the axis so the character would know where he can go. Because our character is also a pawn, we can leave the target without changes. The most simple way and quite effective is to get an actor's forward vector for the direction. Let's combine our pins. For the ability to move to the sides, the steps are the same, except you need to choose the actor's right vector instead. That's it. Next, let's add to our character the ability to look around. Search for Add controller your input. This will go for our turn ability and add controller pitch input. This one will go for our look up and down ability. Let's connect our nodes. And that's it. Next, let's add jump logic. Search for jump and stop jumping. Add them and connect pressed key event to jump and release key event to stop jumping. That's it. For the walk run cycle, we need to create some variables that will store the values for each action respectively. On the left side of your blueprint, find a category named variables. Click on the cross and rename our variable. It's gonna be walk speed. Then go to the right side of your blueprint and change variable type to float. Float type of data stores floating point values, that is, values that have potential decimal places. We need this type for smooth transitions between movement states in future. Then check instance editable and expose on spawn, so we can manipulate with this variable from other blueprints. Then click compile and go back to change the default value. Change it to 300. To change the value for a newly created variable, it needs to be compiled first. Make the same steps for two more variables, run speed and crouch speed. Set the values to 600 and 150. Now, let's reorganize our variables in specific category to keep our work with blueprints cleaner. Click on every variable and in the Details panel, change category to Movement Setup. Now they are beautifully stored under the same folder/category. Compile and save. Let's go back to our Run ability. In the Components panel, choose Character Movement, then drag and drop it to our event graph. Left-click and pull out a wire from a pin and search for Set Max Walk Speed. Copy nodes, simple Ctrl+C, Ctrl+V, and connect them to our action. Then drag and drop walk speed and run speed from our variables. And connect them. Walk speed to our released key, run speed to our pressed key events. Let's reorganize our spaghetti code. Move it here, this here, up, up, like this. Shift A to align it to the left side, and looks beautiful. Next, crouching. Choose character movement. Then on the right side of your blueprint, in details, search for an attribute called can crouch. Check it and go back to the event graph. Right click, search for crouch and uncrouch events. Connect them to press and release key events respectively. After this, we need to make a logic when our variables can affect our character. Right click and search for begin play event. Then let's copy a piece of code where we set up walk speed. Connect them. Then, from character movement, pull out a wire and search for set max walk speed crouched. Connect. Then, from our variables, drag and drop crouch speed and connect it to set max walk speed crouched. Now, when we start our game, our character will receive his basic attunements. Before we check how our character can move, we need to check one more attribute. Choose our camera component and on the right side of your blueprint, search for an attribute called Use Pawn Control Rotation. Check it. Now, our character can look up and down. Now, let's take a brief test. Near the play button, click on the arrow and choose New Editor Pie. Test every ability. Everything works fine. Now let's create our level, our basic level. Here on the content browser, in the folder content, right click and choose new folder, name it maps. Go into maps. Here, right click, choose level, name it as you like, I'll go for sandbox. Enter and choose Save Selected. Now let's set our map as a default map for editor startup and for game launch. Go to Project Settings, then look for Maps and Modes, and under Default Maps, change Editor Startup Map and Game Default Map to our newly created map. That's all. The next thing to do is to create a floor. We will use the landscape, so we can start studying this feature right from the start. Look for a button named Modes on the top side of the screen. Click on it and choose Landscape. Wait for shadows to compile, and for now, we will concentrate on the whole settings. The default setup is quite okay to begin with. We will only change some attributes. Set axis in allocation to 0, and check Enable Edit Layers. Then, click on Create. To quit the mode, choose Modes, then choose Select. That's all. Next, we should add some lighting. We need to add directional light, skylight, sky atmosphere, high exponential fog, and the post-process volume. Look for the Place Actors panel on the left side of the screen and choose all classes. Then, start searching. When you find the necessary element, drag and drop it into the scene. Then we should rearrange our elements' location. I would prefer to keep them in the world's origin position, or 0, 0, 0. Well, that's it. Let's save our map and talk about each element in detail. Right-click on our map, choose Save. The first one, directional light. It's our sun. It simulates light that is being emitted from a source that is infinitely far away. This means that all shadows cast by this light will be parallel, making this the ideal choice for simulating sunlight. It also provides the light shafts. They are generated to simulate the real-world effect of crepuscular rays. These rays add depth and realism to any scene. The next one, skylight. It captures the distant part of your level and applies that to the scene as a light. It affects the light and shadow intensity of the scene, its overall hue, and defines what you can see in reflections from elements that can reflect the light, such as water, glass, etc. The next, sky atmosphere. It's a physically based sky that creates an Earth-like atmosphere with time of day featuring sunrise and sunset. Next, high exponential fog. Simply, it's a fog feature that creates more density in low places of a map and less density in high places. The most noticeable attribute here is volumetric fog. With it, you can support varying densities and any number of lights affecting the fog. It makes your scene very attractive. The last one here is a post-process volume. It gives us a control of the overall look of our scene. Here we can add such features as lens flare, vignette, chromatic aberrations, motion blur, some custom shaders, and so on. We're gonna change only some attributes in all these components just to make a clean mockup to start development with. So let's begin. Firstly, in directional light, let's change its intensity. Look for World Outliner on the right side of your screen. Then select directional light and under category named light, find intensity. Change it from 10 to 2. Then let's change its mobility from the default to movable. And the last one here, let's find and check the attribute called atmosphere/fog sunlight. This will add a sun disk. Next, let's choose skylight and here change its mobility from default one to movable. Next, in high exponential fog, look for fog density and change the default value to 0.005. We skip the sky atmosphere, and the last one is post-process volume. Here we need to check infinite extent attribute. This means that the settings from our volume will affect us in every point of our scene. Think about this as a global post-process. Then we need to adjust exposure. Look for attribute named min/max brightness. Check it and change the values to 1 in both. This will turn off eye adaptation for now. Then look for vignette. Then check it and change the value to 0, so our scene will be equally lighted. When this is done, our reference empty level is ready. Next, let's make our character be able to spawn in a specific place with specific settings. For this, we need to open our player start blueprint. Then right-click on the event graph and search for spawn actor from class. For class, choose our character. Next, we need spawn transform. Right-click on the event graph and search for get actor location. And one more time for make transform. connect these nodes and leave target in getActor location to self. This means that where our player start will be located, exactly the same position will be for our character. Next, connect make transform to spawn transform pin of spawn actor node. Next, we need to possess our character so we can control him. Right click and search for get player controller. Then pull a wire, search for possessors, like this. Next, let's create a reference link to our character so we can use it in future. For this, pull out a wire from the return value of spawn actor node and click on promote to variable. Rename it. And connect all the nodes. Like this. Next, we need to define 3 more variables to adjust character's movement from the world outliner. This is useful when for different levels you can adjust these parameters depending on your plot. We can make it like we did it before using the variables panel, but let's do it in another way. Pull out a wire from every pin defining character's movement and promote them to variables. Rename them. Then compile and save. Now look at the details panel, where you can see that all of them have their default values from their parent class. Now go through all of them and make them editable. Compile and save. Before we test our character, I'd like to apologize because I've made a little mistake. Player start class has inherited component that duplicates our character. So when we spawn our character inside our player start blueprint, we will have one unused and unnecessary character. To deal with it, we can simply reparent our player start blueprint to inherit from a basic actor class. To do this, go to player start blueprint, then look for the class settings button on the top side of your blueprint, click on it and find the parent class under class options category on the right and search for actor. Click on reparent, then compile and save. And one more thing left. You need to add an arrow component to visualize where our character is turned to. Click on the default scene root in components category on your left. Then click on add component and search for arrow. Now go back to event graph. Here, right click and search for get actor rotation. and connect it to make transform node. That's all. Now let's test our player start feature. Drag and drop it into the scene. Then go to the details panel on your right and adjust the movement parameters so you can see the result. Use the Alt-P shortcut to start a game. Everything works fine. Adjust your player start position as you like and save the map. So when you start the game, your character will spawn on the correct place. And I think it's all for this video. A person can't last longer than 30 or 40 minutes concentrated on such a thing, so we'll take a little break. And in the next video, we will create a head bobbing feature to make our movement more attractive and realistic. Thanks for watching, leave a comment and subscribe if you found this video useful.